All right, this video is some notes on applications of trig graphs. So we're going to be looking at real-life trig graphs. This first example is the graph of a height of a Ferris wheel over time. So we start out, we go up, and we come down, and you see our x-axis over here is in time. They ask us first, what is the midline? So this really has nothing to do with anything real life. The midline is just the sinusoidal axis, or the center of this graph, which we can see is y equals 30, or since we're dealing with h, let's call it h equals 30 meters. Next, they're asking us what is the amplitude of a trig graph. The amplitude is the distance from the midline to the peak, or from the midline to the valley. Those should be the same, and in this case they are. Both of them are 25 meters. So the amplitude will be 25 meters. All right, the next question asks, what is the height of the loading platform? For this, let's go ahead and take a look at a Ferris. This is the London Eye, which is a famous Ferris wheel in London. And the loading platform refers to where you board the Ferris wheel, which for this would be down here. Now, oftentimes when you get on the Ferris wheel, you're not at ground level, you walk up some steps or something to get to the base. So that would be the height of the loading platform. Let's also take a minute to look at the motion of a Ferris wheel. When we talk about the position you're in a Ferris wheel, we're going to use a clock, the 1 o'clock position, the 2 o'clock position. And we'll put that clock right on top of the Ferris wheel so that we can say we board at the 6 o'clock position, meaning we're loading at the bottom of the Ferris wheel. If we're spinning at a constant speed, when we go from the 6 o'clock position to the 5 o'clock position, most of our motion has been horizontal. In fact, we've gone up very little. Whereas when we go from the 5 o'clock position to the 4 o'clock position, we have the same amount of horizontal and vertical motion. As we move from 3 o'clock to 4 o'clock, we have very little horizontal motion and a lot of vertical motion. So what we're going to graph is our height over time. This is a little demonstration from the Physics Avery. So in this one, the height over time, we're going to look at this red car here. As the wheel spins around, down here we're graphing time on the x-axis and the height on the y-axis. So if I hit the go button, you can see that my red is going up and it's coming back down. And down here on the bottom, we have this little dot that's moving along to show our location. So rather than make a pointy up and down V-shaped graph, this is going to make a sine curve because it's nice smooth motion. And if you watch the graph down here, the loading platform would be down at the bottom. As I change the height of the loading platform, you can see that my graph moves up and down. So I can do that through the equation or the graph. In my graph, the loading platform would be right here, which means I'm at a height of 5 meters. Question D asks, what is the diameter of the wheel? The diameter of the wheel is the diameter of the circle right here. And you can see as I change the diameter of my wheel, what's changing in my graph is the amplitude of the graph. Since I need to go up 25 meters and down 25 meters from the center, my diameter of my wheel would be the whole 50 meters. Our next question asks, how long does it take for one full revolution of the wheel? A full revolution would mean starting at the bottom, going up to the top, and coming back to the bottom. That'd be right here. This spot is not marked on our graph, but the next one is at 10 minutes. If we take those 5 pieces and divide them into the 10 minutes, then 10 minutes per 5 pieces is 2 minutes for one piece. So this would be 2, 4, 6, 8 minutes. The next question asks, what is the period of the trigonometric function? Well, this is really the same question. How long does it take to make one complete cycle is the period. So the period is also going to be 8 minutes. The next question asks us to write the equation for the graph that doesn't have a phase shift. In other words, we want our anchor point to be right here at t equals 0, not to be shifted to the left or the right. So we probably want to review real quick the different types of trig graphs. The sine of 0 is 0, so a sine curve starts at the origin and goes up from there. The period of the sine curve is 2 pi. That's how long it takes to make a full revolution, going up and then coming down again. The cosine graph looks similar to the sine graph, but the cosine graph starts at a peak because the cosine of 0 is 1. Since it starts at a peak, it's going down from there. The period of our cosine graph, or the amount it takes to make the full cycle, is still 2 pi, just like a sine curve. Well, if we wanted to start somewhere else, like in our graph we started at the bottom, we want to look at reflections of our sine curve and cosine curve. If I put a negative in front of my sine curve, it's going to flip vertically. It'll still start at the origin, but it will go down from that point. If I flip a cosine curve by putting a negative in front, I would then flip, and instead of starting at the top, I'd work at the bottom and go up from there. Our curve that we have has starting at the bottom and going up from there. So my graph is going to be something of the form h equals negative the cosine of t. I'm using h and t because that's what my axes were originally labeled instead of x and y. But I know I need to also make some more modifications. I started out and I looked at what my midline was for my graph. My midline, or the center of my Ferris wheel, was at 30 meters. So I'm going to need to put a plus 30 on the end of this equation to shift the graph up 30. I also changed my amplitude of my graph by having the diameter of 50 for the wheel. But the amplitude of my graph right here was 25, and that's going to stretch my graph vertically by putting a 25 right here in front of the cosine. The last thing that I'm going to need to do is change the period of a regular cosine graph is 2 pi. But my graph has a period of 8 minutes. So I know that normally if I take 2 pi and I divide it by the number that goes into my equation, we call that b in the standard form, that's what gave me my period. If I want to rearrange this equation and multiply b over to the right and divide by the period to figure out what b, the constant, is for my period changer, my horizontal stretcher in here, I can just rearrange, and I have 2 pi over the period equals b. Well, my period was 8 minutes, so 2 pi over 8 will reduce to pi over 4. So pi over 4 is what I need to put in that equation. This equation didn't have a phase shift because it started at the bottom and went to the top. In H, they asked me to write a positive sine equation for the graph. A positive sine equation would start in the middle and go up from there. So when I'm looking at my graph over here, I need to choose a point where I'm in the middle on the way up. The first one I see is right here at t equals 2. So that's where I'm gonna write an H here because this is going to be my anchor point for problem H. So the only thing that will change from my equation in G is I will now have to shift my graph horizontally 2 minutes to the right. So I've rewritten everything the same. I've taken away the negative and changed it to a sign. And how do I move a graph 2 units to the right? I do that by putting a -2 on the inside. So when I'm talking about the inside here, I would have to have the inside separated from my B phase shift because the only thing I'm moving is the T. So be sure you have the double parentheses in there. I and J ask us to write a negative sine equation and a positive cosine equation. So I've copied my equation 2 more times. I'm going to have to insert my phase shifts right here. But let's remember what the graphs look like. The graph for a negative sign would flip over the graph for the sign, so it would start in the middle and then go down. Looking at my picture over here, this happens for the first time right here at 6 minutes. So I'll use that as the start for I. By the way, I could have shifted over here and started the graph at this point. Since I didn't know the time, I'm not going to bother with that, but you could have done that. There's infinitely many correct equations for any trig graph. You just have to choose one of the ones that is correct. For J, you have to write a positive cosine equation. A positive cosine starts up at the peak and then goes around from there. So the logical place to start for me if I wanted to do graph J would be up here at the peak, which was shifted over 4 minutes. So how am I going to shift those graphs? In I need to shift 6 minutes to the right. In order to do that, I put a -6 inside my parentheses. In J, I need to shift my graph 4 minutes to the right. In order to do that, I'll put a -4 inside my parentheses. So those are options for how you could write this equation. When you're looking at answer keys to things, you'll often find many answers for each question because there's lots of different correct answers. There's also lots of wrong ones, so just be sure that your graph works out. On the back of the notes, we're asking you to draw your own trig graphs given an equation, and this time we're doing them without graph paper. So we always gave you graph paper because things would have a nice period, like 2 pi or 4 pi or pi over 2, but nothing weird. And when you're dealing with real life functions, you often get strange periods, like 10 minutes. That doesn't have pi's in it. So let's start with just how would we graph a plain old trig function without any x's drawn for us. First thing we know we have to do is rewrite this in factored form. We have to get this 20 away from the x. It'll still be inside the sign. It's just been separated from the x. When we do that, we're dividing the 20 out to factor it out. So pi over 3 divided by 20 is pi over 60. Remember, you can always check your factoring by if you put the 20 back inside and redistributed it, you would have 20 pi over 60, which would reduce to pi over 3. So you know you have your phase shift correct. The next thing we want to do is we want to start drawing our axes. I usually start with the y-axis, and I make marks for the middle, the maximum, and the minimum. The midline of my graph is going to be moved up 6 with the plus 6 on the end. So the first mark I make on my y-axis is at 6. From there, I'm going to go up and down my amplitude or my vertical stretch. My vertical stretch is 8. So if I do 6 plus 8, that will give me 14. And then if I do 6 minus 8, that will give me -2. Since I don't have any lines on my paper, I would usually take my highlighter and draw lines across at 6, 14, and -2. I love my highlighter. It straightens my lines for me. The next thing that I want to do is I want to draw an x-axis at the appropriate height. So I can't just randomly draw my x-axis down at the bottom. My x-axis would be between the -2 and the 6. So I put my x-axis on there, and next I need to mark my phase shift on the x-axis, followed by 8 equally spaced tick marks. So I'm just going to pop up some tick marks. And I've made sure they're nice and consistently spaced. I haven't worried about what the labels for these are yet. I just know that I need 8 of them, because if I'm going to make 2 full cycles of the graph, or 8 quarter cycles, I will require 9 points to plot because of the extra endpoint. Okay, so now I've got to find the location of these points by repeatedly adding the quarter cycle amount to the phase shift. So let's go ahead and look at what our phase shift and our quarter cycle is. Our phase shift is where we move. We've moved our graph with a minus pi over 60 on the inside. So we've moved our graph pi over 60 to the right. So this first mark right here will be at pi over 60. Next, I need to think of my period. The period for a regular sine function would be 2 pi. But in this case, I've multiplied by 20 on the inside. Multiplying on the inside will have the opposite effect and shrink your graph. So the period is going to be 2 pi over 20. This will reduce to pi over 10. But what I really need to know where to make the next mark is what is a quarter of the cycle. A quarter of the cycle is 1/4 times the period. So a quarter of my reduced pi over 10 would be pi over 40. That means I need to add pi over 40 to pi over 60 to get the next grid mark. In order to add pi over 60 and pi over 40, I need a least common denominator. Since 60 is 2 times 3 times 10, and 40 is 2 times 2 times 10, my least common denominator between those two is going to be 120. I'm going to need to multiply my pi over 60 by 2 on the top and bottom to get 2 pi over 120, and I'll need to multiply my pi over 40 by 3 on the top and bottom to get 3 pi over 120. Then I can add those two things together and get 5 pi over 120. So 5 pi over 120 is what my next mark is going to be. Now I know 5 pi over 120 could be reduced, but I just have to turn it back into 5 pi over 120 to add the next quarter cycle. So it's easier to leave your axis unreduced. So I continually add 3 pi over 120, because that was my pi over 40, my quarter cycle. And that gives me all of the values I need on my x-axis. If you want to start out to double check, if you take your pi over 60 and add to it 2 periods, or you add pi over 10 and pi over 10, that should get you the same thing as when you reduce 26 pi over 120, and it does. Okay, so that's really the most difficult part, is labeling the axis. Now it's just up to plot the points and connect. Remember, a sine curve starts in the middle. So our first point would be on the midline at our phase shift of pi over 60 to the right. Then the sine curve went up, then it went back to the middle, then down to the bottom. Notice where I'm making my mark is at each of my 8 tick marks. Then I'm up at the top, back to the middle, back to the bottom, and back to the middle. The final step is to just make a smooth curve connecting all of these points. So I made my smooth curve and put arrows on both ends. The final example is a graph of a half cycle of a sinusoid. Well, what does that mean? Is this a whole curl right here? No, it's only half. In order to complete the cycle, we'd also have to have an upward part of the curl. By the way, I put this on the right, but it just as easily could have been over here, but then I didn't want to mess with the x-axis. So I'm just going to leave my second half of the graph right here. I have to have one of the bumps that's below the midline and one of the bumps that's above the midline to make it a full sinusoid. So the first question we ask right here is, what is the midline? We know that the midline goes right through the center of the sinusoid. So there it is, mine's a little crooked, sorry. But you can see that the middle of the graph is actually y equals 8. It's not necessarily in the middle of the 2 points they gave you, it's in the middle of the curl from the top and the bottom. So what is the midline? The midline is y equals 8. We need to give a y equals in this case because y is our vertical axis. The next question asks, what is the amplitude? The amplitude is the height from the middle to the bottom, or from the middle to the top. Well, we know this one right here, the middle to the bottom. That's the distance between 2 and 8, which is 6. So our amplitude is 6. I don't have any units on that one because this isn't real life. The next question is, what is the period? What is the period is a little more difficult than the other questions were. The period of the graph is the length it takes to make a full cycle. So from the bottom all the way to the end right here. So I know this amount right here, but that's not a full cycle. That's only half of a cycle. So I'm going to need to double that again to get the full period. So how am I going to find out what this distance is? Well, it's the difference between 4 pi over 7 and pi over 5. So there's half of my period is 4 pi over 7 minus pi over 5. I need to get a common denominator. My common denominator would be 35. So now I have 20 pi over 35 minus 7 pi over 35 is 13 pi over 35. So half of the period is 13 pi over 35. But what I needed was the whole period. So I'm going to have to double my 13 pi over 35. Doubling 13 pi over 35 makes 26 pi over 35. So that is my period. Finally, I'm asked to write an equation for the graph. Now we know that there's infinitely many correct answers for this one, but there's also a few things that will help us get a nicer answer. In this case, I know the value of this location, set pi over 5, and I know the value of this location is 4 pi over 7. So if I'm going to write an equation for this graph, if I want to write a positive sine curve, I should start in the middle going up, and this would be my phase shift of 4 pi over 7. If I want to write a negative sine curve, this would be my phase shift, and I would start at pi over 5 to the right. I'm not going to bother to write a cosine for this one unless they make me, because then I'm going to have to figure out where either one of these 2 points are, and I don't know them already. Pause the video while you give a try, taking into account your midline, your amplitude, your phase shift, and your period, what your equation for the graph could be. All right, so we should start out with y equals regardless of our type of equation. Our amplitude was 6, so we need a multiplier of 6 in front of the sine curve. If we're starting from this orange star right here, then it's going to be a positive 6. If your phase shift is this black dot, then you would have a negative 6 in front of your sine. All right, the next thing we need on the inside here is the stretcher, the horizontal stretcher. So the horizontal stretcher is 2 pi over the period, or what you have to do to 2 pi to turn it into this number. 2 pi divided by our period of 26 pi over 35 is the same as 2 pi times 35 over 26 if I take the reciprocal of that. So my pi's would reduce out, my 2 would reduce with my 26, and I would have 35 pi, or sorry, no pi left, 35 over 13. So 35 over 13 is my horizontal stretcher that goes inside here. Then I have another parentheses so that the phase shift just affects x. Again, if I'm starting at the orange star point, my phase shift was the 4 pi over 7 to the right. If I started at the black dot, my phase shift down here was pi over 5 to the right. The last thing that goes on the end is the vertical mover, or our midline change. I moved my midline up to y equals 8 instead of revolving around the x-axis, so I need a plus 8 on the end of any equation to show that I move my graph up 8. Good luck on your practice. Remember, these have lots of answers, and you have to try different things until you can figure